Hey everyone, I am just recording a quick video to help you if you struggled with either the Nearpod lesson from yesterday or the quiz from today. I'm going to be going over select parts of each of those assignments in case you need it. So I'm just going to jump right in. The first question had to do with these three graphs. So I'm not sure if it was super clear in the instructions, but this black dot right here is representing the mean of the parameter, and the mean of each of these graphs is going to be right down the center where the highest point is. So the mean of this graph is here, the mean of this graph is here, the mean of this one is here. So you can see in the first two graphs the mean of the statistic and the parameter are very close together, and in this particular graph right here the mean of the parameter is outside of the mean of the means are not the same. And the first two would be unbiased. So this would be unbiased, and as would this one. Okay. The second thing we were talking about is variability. And to see which one is least variable, most variable, you just want to look at how wide each of these is. And we're assuming that they're in the same scale. They might not be, but if they weren't, we definitely have that at the bottom of the scale so that you can see the difference. But we're assuming that all these have the same scale. And so this one right here is the least variable. Then I would say probably this one, and then this one is probably the most variable if I'm just eyeballing it. So this one would be least variable. This one would be most variable. So keeping that in mind, which of these three graphs is preferred, which one is the best for describing the data, and explain why it is the best. So the one that is the best is A. And A is best because it is both unbiased and the least variable. Okay, the next question, let's see if I can adjust this a little bit. Alright, so the next question has to do with the Hockey League owners' lockout resulting in the cancellation of what would have been the 88th season of NHL. It was the first time the Stanley Cup was not awarded since 1919, and the first time a major professional sports league in North America had canceled a complete season because of a labor dispute. In 2005, the Gallup poll asked a sample of 620 Canadian adults whether their support of hockey had been affected by the recent lockout, and 248 people in the sample said yes. So you're being asked to identify the population, the parameter of the sample, and the statistic for this particular example. So your population is all Canadian adults. And your sample is the 620 in the SRS. And your parameter would be, it's not really said in here what the parameter is exactly, like we don't have a number that goes with it, but you can describe it as being the people in the population that had an effect on their support of hockey. And the statistic would be the 248 people who said yes. So the 248 people is representing the actual, or you can say that you could make an inference of the actual number of people that would agree to this statement based on the 248 people of the 620 that said yes. All right, so number 4, about 10% of people in the U.S. have blood type B. Suppose we take a random sample of 120 people and let X be the number of people with type B blood. We want to calculate the mean, and the mean is calculated by taking N times P. And in this case, N is this random sample of 120 people, and our probability is 10%. So if we take 120 times 0.10, we get 12 people. And your standard deviation is going to be N times P times 1 minus P, and you're going to take the square root of all of that. So 120 times 0.10 times 0.9 square root. You always want to round this to 2 decimal places. Since it's 3.286, we want to round that to 3.29. Okay, justify that the distribution of X is approximately normal. We use the large counts condition to do this. Large counts condition states that N times P has to be greater than or equal to 10, and N times 1 minus P has to be greater than or equal to 10. So in this case, we would take the 120 times 0.1, and that is equal to, what a mess. 12, which is greater than or equal to 10, and then we would take 120 times 0.9, and that's going to be equal to 108, which is also greater than or equal to 10. So it is justified. You have to have these calculations. You can't just say it's greater than or equal to 10. Show me the numbers. So in some way, shape, or form, you have to type in when you do these those calculations so I can see you know those formulas. The next thing is to calculate the probability that 16 or more individuals in the sample have type B blood. So we would take 16 minus the mean of 12 over the z-score of 3.29. Okay, one of the common mistakes I see a lot of you making is instead of doing this in 2 different processes or putting in parentheses, you're trying to do it as all one equation. And look at what happens if I don't use parentheses and I do it all as one equation. You're not going to get the right answer. So if you're getting z-scores that are really, really high, this is why. So you want to make sure a z-score should never be more than plus or minus 3 from the mean. If you're getting a number that's way higher than 3 or way lower than negative 3, then you're probably making this mistake because your calculator does order of operations. So it's going to take the 12 and divide 3.29 first, and then it's going to subtract that from 16. And that's why you're getting those errors. So in this case, since it's 1.215, we would round that to 1.22. You then want to get your z-score sheet and look up that z-score 1.22. So, oops. Find the 1.2 column right here, and then carry that over to, 1.2 column, carry that over to 1.22, you get 0.8888. Okay, but the one thing I want to caution you on is if I were to draw this, we're looking for 16 or more. If this is 12, 16 is going to be over here somewhere, and we're going to be shading in this direction. And since we're shading on the right-hand side and the z-score sheet or the table A only gives us the left-hand side, you have to subtract the 0.8888 from 1. So you should be getting 0.1112 or 11.12% for that one. All right, next I wanted to talk about just the quiz real quick. Just a couple of questions from the quiz. I'm not going to do all of them, but the first one was the SAT scores and the population sample parameter statistic. Again, just to make sure that you understand this part. Your population are going to be all SAT scores. Or I think the way that I worded it on the quiz was all high school students. Your sample is going to be just the 100 students taken in the sample. Your parameter is the thing, the number that describes all SAT scores, and the average SAT score was 516. And your statistic is going to be the number that describes the score of these 100 students, and that is 486. All right, so the next thing is a doctor reads a med article stating that 82% of female patients are vitamin D deficient. She chose a random sample of 45 medical files. Let X be the number of female patients that are vitamin D deficient. Calculate the mean and the standard deviation. So you want to take N times 0.82. That's going to give you your mean of 36.9. And then we want the standard deviation, which is going to be 45 times 0.82 times 0.18, and the square root of that. So that gives you 2.58. And the last thing is to interpret that. And so the number of people with vitamin D deficiency typically varies from the mean of 36.9 by 2.58. And the last thing is the probability that fewer than 30 female patients will be vitamin D deficient. So you need a z-score 30 minus 36.9 over 2.58. Gives you a z-score of negative 2.67. Negative 2.6 over to the 7 column is 0.0038. And if we're drawing this one, we're looking at our mean of 36.9. 30 is on this side, and we're looking for people that have fewer than 30. So we're looking at shading the left-hand side, so we do not have to subtract from 0. We just want to convert that to a percent, which is 0.38%. Hopefully that was helpful. If you look at this and you're still confused on anything, please feel free to email me. we'll be able to answer questions for a couple more hours now. Hopefully that helped, and I'll see you soon.